Hi, my name is Nur Hazairi bin Wisham. My matrix number is A203910. Today I want to perform my final assessment for this course. So for the question 1, we need to propose a circuit with drawing that yield the result in figure 2, which is this figure. We need to make a circuit that produce this signal, and for my matrix number is A203910, which is ending with 0. 0 is an even number, so I need to choose 1B. So moving on to Ltspice simulation. So for the first question 1, we need to put all of the components first. So firstly, put the voltage source, and then put the resistor. We need to rotate the resistor, and then the inductor, and lastly the ground. Put the ground, and then connect it with wire. Connect all of the component with wire. And lastly, and after that, just put the value for all of the component. For voltage source, we need to click advance, click this sign, and put the value. So for the amplitude, I put 5. For the frequency, I put 8. And for the degree, I put 90. So, and then click OK. And then put the value for R1. Just click it. I put the value for R1 is 1 k ohm. And for the inductor L1, I put 50. And lastly, we need to label the V in and V out. V in here and V out here. Click here. Click here. I put here. Then click here again and do the same thing that V in, this is for V out, and I put here. Sorry. And then I want to run the circuit first. So for the stop time, according to the question, we need to put the stop time is our stop time is 250 milliseconds. Put it here. So this is our output signal. You can see this is our output signal. So this is my calculation
for this assignment, and this is for question 1. As you can see, this is my circuit drawing for question 1, and we need to find VT and VL for this question. So the formula to find VT is equal to Vin. Vin is equal to IR plus Vout, and then VL is equals to Vout. Vout is equals to I times J times omega times L. So as you know, Vin is equals to 5 volt with 90 degree, and our frequency is 8 Hz. And then we need to find Z total first. The formula to find Z total is Z total is equals to ZR plus ZL. ZL we can obtain by this equation, J times W times L. For ZR is equal ZR is equals to 1000 ohms, which is this, plus with J times 16 pi times 15, and then we will get 1252.39, 0.65 degree. We need to find I. The formula to find I is Vs divided by Zt. So the answer is 4 times 10 power negative 3 with 1.39 degree. And then find Vr. The formula to find Vr is I times R. The answer is 4 with the degree of 1.39 degree. Next step, find VL. As we know, VL is equals to Vout. 4 and 1.39 degree times J times 16 pi times 15. The answer is 3.02 volt with 2.96 degree. Lastly, we need to find VT. VT is equals to Vin. 4 and 1.39 degree plus 302 volt with 2.96 degree, and the answer is 5.01 volt with degree of 2.04 degree. And lastly, find phase shift. The formula to find phase shift is tan the power of negative 1 omega L divided by R, and then the answer is 0.64 degree. And I think that's it for question 1. Moving on to question 2. For question number 2, we need to propose a circuit with drawing that yield the result in figure 3, which is this figure 3. So for my case, my matrix number is A203910, which is ending with 0. 0 is an even number, so I need to answer 1B. For those matrix number ending with even number, please use resistor and capacitor. So I need to use capacitor and resistor to answer this question. So let's begin.
So for the question 2B, same like question 1. So first we need to put all of the component such as voltage source, resistor, capacitor, and resistor 2, and lastly capacitor. And don't forget to put ground also. And then connect all of the component with wire. Connect all of this with wire, and lastly we need to put the value for each of the component. So for the V1, we don't have to put any value, we just put AC. For R1 I put 1K, I just assume 1K. And for C1 I just put 0.159 micro. R2 is 3K. C2 is 5.3 N. And then don't forget to label the V in and V out for this circuit. So and then we need to go to simulate, which is here. Just click here and click run or pause. Click that. We don't use transient because we need to use AC analysis. For the type of speed, we need to choose decade. Number of movement per decade is 10,000. Start frequency is 1 and stop frequency is 100,000 K. And then click OK. So we need to click at V in first. Click that, and then click at V out. So this is our output signal. So for this is gain, which is V out over V in. This is gain. This is the shade of gain, and then this the below one is phase shifter. So I think this is the final output for question 2B. So moving on to calculation part. So
for the calculation for question 2B, first of all, this circuit is a band stop filter. It is obtained by low pass and high pass filter are connected in parallel. So next, the value of FL is 1 kHz. The value of FC is 5 kHz, and value for FH is 10 kHz. So in order to prove that, we need to find the value of R1 and C1 and value of R2 and C2. And then the value of R1 and C1 is R1 times C1 is 0.00015. The value of R2 times C2 is 1.59 times 10 power of negative 5. And then we just use simultaneous equation. Assume R1 is 1 kilo ohm and R2 is 3 kilo ohms. And then the final answer for capacitor 1 is 0.159 nanofarad, and for the capacitor 2, the value of capacitor 2 is 5.9 nanofarad. So this is the final value for C1 and C2. So I think this is the end of my video. So I think that's all from me. Thank you.